All right, I'm going to do a fairly in-depth review of the list assignment, what was expected, some solutions I got, and what I think are probably um, ideal or sufficiently ideal solutions. So the first thing I asked us to do on the list assignment was, obviously it's an introduction to lists, so we need to make a list. In our variables tab, there is a option for making a variable. Hopefully we've all seen that multiple times. Today we're going to be clicking make a list. A list is kind of like a variable. It has a name. We're going to name this one number list. And it holds value, but it doesn't hold one value like a variable holds one value. A list can hold lots and lots and lots of values. Each of those values could kind of be thought of as a variable. Named, number list item 1 would be a variable. Could be one way to think about a list. The first thing I wanted to do is I wanted to initialize the list. So let's make a my block that just make a random list. This wasn't written in the instructions. I just had you add a few random things to the list. So in the instructions it said add 1, 2, some random numbers, just so that we would have a list that we could start working with. That is fine for the submission, but what I'm going to do, I'm going to make it so we have a function, make a random list, that adds a few random values to our list. So when we start, it'll just add some random numbers to our list. So when the game starts, it's going to make a random list. The make a random list function adds a random number for 1 to 10 to the list, and it does that 1, 2, 3, 4, 5, 6 times. Instead of doing the same block 6 times over and over again, we could just repeat that, let's say 6 times. And since I'm being, trying to make some ideal solutions, maybe I'll give this an input and I'll say some number, maybe num. I don't know. I'll just call it num. It doesn't really matter. And maybe instead of repeating it 6 times, I'll repeat it some number of times. And now maybe I'll make a random list of size 6, which isn't really going to work. This is going to add 6 things to this list. So right now it's 8. It's going to add 6 random things to this list. What I would need if I wanted to make a new list every time, I'll make another block and I'll call it, actually there's already a block for this. There is a delete all of number list. I'll make it so when I press the letter D, it deletes all of the list. So D to delete the whole list, and then I'll click the green flag and I'll get some initialized list with 6 values. Maybe I could press D again, and maybe I'll actually start with 10 values. Let's start with 10. We have some list, we have some values. I wanted to do a few things. I wanted you guys to make it so I could give a range of numbers and you would create a list in that range of numbers. So for example, if you wrote 5 to 7, the list would be 5, 6, 7. If you wrote 1 to 100, the list would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 100. The way a lot of students did that is they started off with this. They started off by saying, make a list from, let's say, 1 to 10, no inputs, hard-coded. And they started off by saying, okay, make a list from 1 to 10. Let's add 1. Let's add 2. Let's add 3. Let's add 4. Let's add 5. Let's add 6. Let's add 7. Let's add 8. Let's add 9 and 10. And they were like, okay. And actually, this should delete everything in the list already there. So this is going to delete everything in our list. And it's going to give us a list from 1 to 10. It seems like it works. Sure. But I didn't want a hard-coded list within a set of numbers that gives us that specific set. I wanted to create a my block that creates a list, create a list from some number that we give it to some other number that we give it. I'm going to call this number bigger, and I'm going to call this number smaller. And I'm actually also going to write num at the end, just to remind us that this input should be a number. Bigger num and smaller num. So those will be our 2 input variables. And when some students were thinking about this, they were like, okay, so it needs to be in some range. I made some code to make numbers from 1 to 10. That's in some range. Maybe I could do this again, but this time I'll add some conditionals. And this is a way that I accepted the submission. This is something I was recommending kids try. Like, this is something I was leading kids towards if they were very stuck. And they could say, if 1 is bigger than the smaller number, and 1 is less than, and it's less than the bigger number, then we should add 1 to our list. So if it's in between these two numbers, we'll add 1 to our list. And I had students who did that for every number from 1 to 10, which could make it so that they could get that list from 1 to 10. I'm just going to do, I'll just do 1, 2, 3, 4, just because I don't want to sit here. Actually, you know what? We'll do it correctly. We'll do it everything. 5, 6. There's going to be some problems with this that I'm not going to fix all the way, but we'll just address those. All right. So now what this is going to do, it's not going to add every number from 1 to 10. When I run this block, create numbers from blank to blank, it doesn't add anything right now because this is technically in Scratch from 0 to 0. When a variable isn't initialized, when we don't give it a value on an input, it sets it to 0 automatically. So create a list from 0 to 0. There's nothing there. There's no values in between 0 and 0 on this list. Maybe I could try to create a list from 3 to 9. And this is going to be exclusive. It's not going to include these two values. Let's try that. Okay, so it creates a list with every number in between 3 and 9. So it looks like that's kind of working, kind of doing what we wanted. Maybe if I do, 6 to 10, maybe if I do actually, let's do a different example first, just to show something else. Maybe 1 to 3. Okay, 2 is in between 1 and 3. That's the only value you got. Okay, so it's kind of working. If we wanted to make this inclusive, that's a good problem for you guys to think about, actually. This is kind of called an off by 1 error. We're kind of off by 1 on both sides. You guys can maybe think about how to fix that on your own. But what I'm going to say is that this solution, we're kind of hard coding each answer. I had students who had this working from, negative infinity to infinity. Not technically, but what I mean to say is any two values that I put in here that were like legal values under, 2 to the 256 or whatever the biggest number you could do is. I have no idea. It's probably much smaller than that, actually, but it doesn't really matter. Anyway, I had students who made it so that this function works for any legal values, for any values that we could put into this function. So if they did, if I try with mine, if I try to do from 10 to 20, nothing's going to show up because I didn't put all the values from 11 to 12 to 13 to 14. And it would take me an infinite amount of time to put in an infinite number of values. It would be a huge waste of my time. I wouldn't want to spend my whole life just inputting useless values to this ever-growing function. It doesn't make any sense. So my students came up with a really clever idea. I had one student come up with this idea, and it's the one I loved the most. Let me think if I can do it off the top of my head. What my student decided is that we should clear our list. Obviously, we should start by deleting everything else because we're going to make a new list. We should repeat until, maybe I should just pull up his example to this problem. But he did, oh, here it is. It's so sweet. It's so tiny. He wrote 1 to 10. This works for every number. This is his example, 16,000 to 50,000. And it just works. It does every single value. What this is doing, it's adding the smallest number to the list. And then it's repeating. It's going to repeatedly add one thing to the list until the number list contains the biggest number. Beautiful, 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 beautiful. We've never even used this true-false value before. This Boolean right here, we've actually never even used it. And he just whipped that out and made something absolutely beautiful. So we're going to repeat until, we're going to add the smaller number to the list. We're going to repeat until number list contains the bigger number. And we're just going to add What did he add? The biggest number? Add 1 plus the length. Wait. Oh, 1 is the smallest number. Okay, smallest number plus the length. So smallest number is the first thing. And then smallest number plus 1, smallest number plus 2, smallest number plus 3. Wouldn't this be off by 1? Oh, because it's inclusive. Oh my god, this is... Okay. Anyway, this is just such a beautiful solution. It is adding the smallest number to the list, and then it's adding the smallest number plus length of list is 1 because we currently have the smallest number on it. So it's adding smallest number plus 1, and then it's adding smallest number plus 2, and then it's adding smallest number plus 3. This is like a genius solution. This is like such a beautiful solution. So let's write that in. So add smallest number plus length of list. Plus length of list. That's another little variable that we haven't used. So we start and our list is at 0. We add the smallest number. Now our list length is 1. I'm just going to put a wait so I can watch this happen in real time. I'm going to wait 0.5 seconds. So if I create a list from 167 to 252, we start at 167, and then it adds, I'm going to make this wait really long, 2 seconds. So we start at 167. It's going to add 167 plus the current length is 1 because we have the 167, 168 plus 167 plus the current length is 2. That's really beautiful. Really, really, really good understanding of how lists work to make that little algorithm. So I wanted us to make this. I wanted us to make something to add value to each number of the list. So for example, whatever the size of the list is, I wanted us to, let's create a block that add input value to all entries, to actually just say to each. So add value to each. So this is going to add some number to each value on the list. So we will loop length of list times. So we're going to loop through each entry on the list. So we're going to loop length of the list. And we'll have a variable called counter. We'll start at 0. And we'll change it by 1 each time. And we will check, we're going to replace item 1. We're going to replace item variable of the list. So we're going to start at 0. Variable is going to be 1. We're going to change item 1 to item 1 to item variable plus 1. So this variable is just a counter that counts how many times we've gone through this loop. And each time we go through this loop, we're going to change a different variable on the loop. We're going to change a different entry on the loop. And we're going to change it by 1. Let's start by doing plus 1. So this isn't exactly what I want yet. Nope, that's not correct. It's going to be item by variable, and item by variable is going to be increased by 1. So when I run that block, add value to each, it's going to put every value up by 1. But I don't necessarily want to put those values up by 1. I wanted to put those values up by some number that I tell it. So instead of using 1, we could say value, and then whatever value I input here is how much it's going to go up. So if I say 10, every number on this list goes up by 10. If I say 100, every number on this list goes up by 100. If I say 200, every number on this list goes up by 200. Again, for this one, I had kids who hard-coded it, who made it so entry 1 would go up by 1, entry 2 would go up by 1. I wanted us using repeat blocks. It's very difficult to think abstractly, especially with a really, really, really new concept like lists. But I wanted us to use repeat blocks to see the value of this. In fact, I'm going to make it an assignment for every student to go back and just resubmit a new copy of this assignment with these specific loops. Even if you don't understand them, writing them out, seeing them, seeing how beautifully and amazingly this work can be done, seeing the potential of code is a really good thing. So I'm going to make every single student write these lists out. So we can make a random list. We can add set numbers to that list. We can create a list from any two numbers. The last thing I wanted is I wanted to make a block that makes a backwards list. Now this one was the hardest one for my students, and none of them had a really beautiful solution. Some of them had very simple things that would swap specific entries in the list. A lot of them used a really important concept, which is making a dummy list that just temporarily holds values while this function is working, while this my block is working. So we'll make a backwards list. So this backwards list is going to be set to number list, but backwards, and then we'll copy backwards list into number list when we're done working. And that'll give us a backwards version of number list. So we're going to reverse whatever number list we have. We're going to make it but backwards. It's going to be similar. We're going to have a repeat block. We're going to repeat number of entries times. So we're going to repeat for each entry. So we're going to repeat for the length of number list. And for the length of number list, for each entry number list, we're going to have another variable. Let's set my variable. We could use the same counter as before, since we should never be running both of these functions simultaneously. We'll set my variable to 0. We'll count by 1. We'll start with the last entry in list. So we'll do item number. So we'll replace item number. Actually, we should just insert items to backwards list. So we should just add items to backwards list. And the thing we're adding to backwards list is going to be the item number length of list minus my variable. So that was, I just said a lot of things very quickly, but let me explain what this is going to do. Minus my variable. This is going to start, and on the first loop, it's going to add item number length of list. It's going to add length of item number length of list. The length of the list is 25. Item number 25 is the last number. Whatever the length of the list is, that's going to be our last number. So it's going to add the last number to the backwards list. That's what this does. Item number length of number list in number list to backwards list. Item number of thing. No, it needs to be item. This was the wrong block. We're looking for this one. So item length of backwards list. Item length of number list is 25. We want item number 25 of number list to be added to backwards list. So now this block adds the last number to backwards list. And then on the next loop, we'll add the next number minus 1. And then we'll add what is my variable right now? Set my variable to 0. Change my variable by 1. So it's adding the last number, and now it's adding the second to last number. And now if I change it by 1, and then I run this, it's going to add the third to last number. And then if I change my variable by 1, if I increase this number by 1, now it's going back 1, 2, 3. Now it's going to do the fourth to last number. Oh, I just set it back to 0. Whoops. 0, 1, 2, 3, 4. 2, 3, 4. And we could keep increasing this variable and then adding that number to this list. This will probably be more clear if I run it, maybe with some weights, so we could watch the magic happen. So I'm going to clear the backwards list, and I'm going to clear number list. So I'm going to delete all of backwards list, delete all of number list. And we're going to make a random list from, let's make a random list 20. Okay, so we have a random list, and when we run this, what it's going to do, it's going to start at 0. It's going to repeat for each entry in number list for the full length of number list. It's going to change this variable by 1. So it's going to start at 1. And it's going to add item length of number list minus 1. Nope, this should happen first. It's going to add length of number list, which is 20. It's going to add the last number. And then it's going to add the last number minus 1. And then it's going to add the last number minus 2, which is going to give us a beautiful backwards list. Now, I want to do one more thing. This backwards list is now this list, but backwards. I don't want to use backwards list for anything besides just a placeholder. Now that we've created the backwards list, we're going to set. Oh, we really have to do it manually? Okay, I'm not going to go through all that trouble. We have backwards list. It's the list backwards. I will take this as the solution. A problem some kids were having when they weren't using a second list is they were copying values. So they would try to set this list to be backwards. They would loop through it. They'd set entry number 1 to 20. Then they set entry number 19 to 2. Then they'd set entry number 18. I'm sorry, they'd set entry number 3 to 18. Then they'd set entry number 4 to 17. Then they'd set entry number 5 to 16. Then they'd set this, they'd set this, they'd set this. And then once they got to the bigger numbers, they'd start setting the bigger numbers to the smaller numbers. But the small numbers had already been changed to the bigger numbers, which causes a glitch. So that was a common problem. That's why we need to use 2 lists. I'm getting a little tired. I'll admit it. This was a very complicated lab. This is probably the most complicated we've done so far. There's some very complex algorithms in here. I saw a lot of really, really amazing solutions for my students, a very wide range of things. I think these are the most ideal solutions to what I was looking for. If you submit this with these 4 algorithms, I'll be very happy with you. I'm going to make this its own assignment for tomorrow, and we'll say it takes the full video length plus 5 minutes. Yeah, I'll explain it tomorrow, but this is the ideal solution to Lab 5A. Lab 5A, ideal solution, or unideal solution. There could be maybe multiple other more or less closer ideal solutions. I'm not perfect. I'm not saying my code is perfect. I definitely don't perfectly like how my backwards code works, by the way. So it's definitely not ideal, but it's close enough. All right. Anyway, hopefully that's helpful. I know it's helpful because I know some kids who are just going to be like, oh, look, he gave me some answers. And they're going to be very happy. And I know some kids who are going to be like, oh, wow, that's really impressive how much work we can do this with these repeats. I'm going to try to use repeats a lot more in the future. So overall, I think this should have a positive impact on the class. If I see kids who just copy answers and then don't know what they mean and don't know the code and don't understand things, then I will be more hesitant to do things like this in the future. But a lot of kids struggled with this, so I am going to make the video, and hopefully it helps. Good luck. Please email me if you need anything in the whole world. You are all amazing. I cannot express to you how fantastic all of the work has been up to this point. Even on this lab, so many students doing amazing things. Alexis, Reese, Xavier, Derek, Kenny gave me some really cool things. Just keep up the good work. You guys are amazing, 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 super amazing, double super amazing. I'm gonna head out. Good luck. Email me if you need anything. I'm rambling. Goodbye.